climate change is one major ongoing human impact on the environment. I've got a link here if you're interested, some statistics on the current conditions. Now the problem is not that there's one magic temperature that's the best for the Earth. Climate does vary naturally. We're actually in a somewhat cooler period compared to the long-term average over the past, actually over 500 million years. But the thing is that climate is changing quickly. It's changing faster than some people and plants and animals and other organisms are able to adjust. That's what the problem is, not that there's just one temperature that's the option. And this rapid change does not match with any natural cause, does match with all the carbon dioxide and other greenhouse gases that humans are putting out there. It's pretty clear, yes, change is happening. It is largely because of what we're doing, and there are a number of negative effects. What is a lot more challenging in terms of assessing what to do is kind of what's going to be the best solution. That brings in ethics, economics, a lot of other things, not just the science data of do we have a problem. Our warmest years over the past well over a century are all in the past several years. And we're seeing more change as we continue on into the 21st century. This is a graph of our average temperature. No, yes, temperature goes up and down. You've noticed, some days are cold, some days are warm. But the overall trend is pretty obvious. We're seeing more warm, fewer cold as we go along. A lot of study going into this. The United Nations has a committee, Intergovernmental Panel on Climate Change, that tries to gather all the information available and summarize what we know currently. And as best we can tell, human-caused factors have caused most of the climate change that we've seen over the past 50 years, even more. I mean, we've been burning wood for a very long time, and some burning of coal going back for quite a while, but kind of late 1600s, early 1700s is when things got going with the Industrial Revolution a lot more. So very much over the past 3 centuries, we've had quite a lot. Over the next few decades, we're likely to see significant increases in temperature. Now, 0.2 degrees Celsius, that doesn't sound like that much. And if the temperature in the room went up by that, you'd have a hard time noticing. But the total global average going up by that much has significant impacts. Global average, some places are getting a lot warmer. Some places actually get cooler, some don't change that much. And average across the whole time, this is shifting to warmer conditions, putting new stresses on organisms, and we're seeing significant problems affecting not just in the wild, but humans as well. The committee has had significant contribution by Christians and as well as others. One of the first chairs of it, John Houghton, for example, a strong evangelical background. Actually, he just recently died from probably the coronavirus, although he was in declining health before that. Here's a listing of the change in levels of different greenhouse gases. Natural levels versus the amount more modern. This is, we've gone significantly past that for the carbon dioxide. These result from a variety of things. Carbon dioxide mainly from burning stuff. Methane, some of this is released by leaks with getting oil and natural gas. Some of it comes from land use changes, promoting the release of methane that had been trapped down in soil and swamps and things like that. Also agriculture, intensive raising of things like cattle. They put out methane mostly by burping. Nitrous oxide, the ozone, those tend to be related to a large extent with burning as well. The CFCs, chlorofluorocarbons, these are chemicals that we have made and found that they were useful for various functions, but then found they have some harmful effects as well. In particular, as these get mixed around with the air, get high in the air, they can help to break down the ozone layer of the stratosphere. Tropospheric ozone down here is a problem. Ozone is quite reactive. It's bad for you. If you keep it contained, you can use it to kill germs. But up in the stratosphere, that ozone layer there is major for blocking UV. And so it helps keep us from getting skin cancer and sunburn and all that bad stuff. When the chlorofluorocarbons mix up to there, they become quite reactive, breaking into things that do a very good job of destroying lots of ozone. So it was recognized these have problems, even though they're great for making refrigerators and aerosol cans, but the problem's significant. And so international agreements were made to try to eliminate use of those, and the concentrations have gone down. They also have big greenhouse gases. That's actually decreased. Warming's not nearly as bad as it would have been if we kept on using these the way we used to. But the decline in these has slowed somewhat. Turns out there are factories in China illegally still making these sorts of things because they're useful. Companies will buy them. So we do have problems like that as well. Impacts of climate change. Rising sea level. So coastal areas are getting flooded and all the problems associated with that, whether it's the people or other living things in these areas. Shifts in patterns of precipitation. Actually, here in the Carolinas, don't see as much temperature change as many parts of the world from the climate change, but we do tend to see shifts in patterns of rainfall from more spread out, moderate rain to fewer, bigger storms. And of course, bigger storm, that's more likely to give you flooding, less likely to nicely soak the ground and give the plants what they need. So you've got problems there. Some places are getting wetter, some drier, and either sort of change can give you trouble. Of course, biological diversity, living things. Not too many are going to be just killed straight out by the heat. But heat's a stress, added to all the other things, and can lead to declines. And not just the wild, but the living things we care about for practical purposes, agriculture. The plants and animals we're growing, they're impacted. What will have to happen is actually having ways to use up that carbon dioxide. There are lots of steps in the carbon cycle, but we're all of a sudden putting lots more into the air. The rest of the system has got to catch up, which will take a while. Now, there may be some things we can do, but it takes effort, and of course also, if we can decrease how much we're putting in the air, that would make it easier to catch up and do something about it. Even when carbon dioxide levels stop increasing, the change in the environment will take a while to totally catch up with the effects of the new condition. So what we've already burnt is having effects even if we were to stop right now all our burning of fossil fuels, we would see continued change happening because of the effect of what's already there. We're at a fine line. It doesn't take very much change in temperature to have either major melting of glaciers if we get warmer, or to have glaciers expanding quite dramatically if we get a little colder. We're kind of right near the boundary at present, so a small change can lead to some pretty big effects. Melting, of course, that's more water that's going to be rising sea level. Also, water, when it gets warmer, ignoring the weird things it does right near freezing, gets bigger. And so we warm up the oceans, the ocean expands, which means the level is going to be rising with that as well. So we see rises in sea level. Already, coastal cities like Miami, like Charleston, South Carolina, are having increased problems with flooding compared to historically the pattern. Hampton Roads area in Virginia, another area very severely impacted by just a little sea level rise. And by 2100, it's estimated that we'll see rises in sea level at least around 18 centimeters, perhaps as much as over half a meter. And this will give significant flooding in low-lying coastal areas, which describes practically the whole state of Florida as a low-lying coastal area. Louisiana, a lot of eastern North Carolina is quite low-lying. It doesn't take a whole lot of sea level rise before, say, Lake Matamuskie is Bay Matamuskie. And there are other countries at risk, whether the small island countries out in the Pacific, where they don't have any higher land, but also there are a number of coastal countries that have extensive low-lying areas. And in some, such as Egypt, that's most of the habitable area. Yeah, they've got higher areas. It's a desert. Not so great to try to live there. This is an example of change. This is a map of a part of southern Louisiana in 1990. By 2014, it looked like this. Now, part of this is rise in sea level with very low-lying land. Doesn't take much to flood a whole lot of it. Also, Louisiana, a good deal of it is sinking for a few different reasons. Also, our fault. And that combination means that what used to be, for example, Dr. Jones knows somebody with a fishing shack out here. Used to be a half-hour drive to get there. Now it's more like a 2-hour boat ride to get there. If you're interested, I've got a link here. You can look at forecasts for coastline around the U.S., areas that are particularly vulnerable for flooding. Changing precipitation patterns. Some areas are likely to see somewhat less rain, greater drought. We're seeing significant drought in western U.S. Of course, news for California particularly acute, but more general across the western U.S. They're having low water amounts, less rain, and problems, and it looks to be as bad overall long term as it's been for well over 1,000 years. Other areas may see increased storms, snow, or rain. Melting. Places that relied on snow melting in the spring for a lot of their river water, we'll see less of that. Problems there. Warmer sea surface temperature. We'll see more evaporation, more water in the air, and potentially more powerful storms. A vivid example of that, Hurricane Harvey, couple years back now in Texas, the Weather Service actually had to expand their scale of rainfall. So much rain came. There was a huge amount of very warm, wet air sitting over Texas and just sitting there and raining and raining and raining. Warmer air, there's more evaporation, you have more moisture, and thus more rain. Living things, temperature changes, shift the seasons, we see differences. When do we see flowers? When do different types of organisms breed? These types of things. There are a variety of clues that living things can use. As climate changes, stuff may get out of sync, and so a species that needs something might be showing up at the wrong time for it as conditions shift. For example, consider the basic question, how do you know if it's spring? Well, there are various clues you might rely on. I look outside, I see new leaves and flowers and things like that. Okay, and some living things can check what's happening around them and follow suit. Another possible clue would be, hey, it's getting warm outside. That's a useful clue. Some things use that. But again, there could be problems. For example, hey, here's a warm day. Oh, we get a few warm days here and there scattered through the winter. A plant starts to put out its buds, and then all of a sudden turns cold again. That plant may be in serious trouble. So, judging what really is good enough warmth to say it's really spring and not just a brief thaw, there's a challenge there. Another thing, I mean, we could look at the calendar and say, hey, the calendar says it's spring. Now, of course, plants and animals can't look at the calendar. Well, animals could look at it, but it wouldn't do any good. But they can detect how long the days are. In spring, days are getting longer. In fall, they're getting shorter. And so this gives a clue to what time of year it is and can tell when it's time to do something. But coordinating, if one organism is relying on one clue, a different clue, and those two organisms interact, there could be problems. For example, migrating birds. A lot of our birds that we have around in the summertime fly to the Caribbean or South America for the winter and then come back again. They're coming here for nesting to be able to get that bumper crop of bugs that you get as the plants start to leaf out and flower in the springtime. A bird in South America can't look around and see if it's warm in Boiling Springs. It's got to rely on something like day length as a calendar clue to say it's time to go back. But if, due to warmer conditions, the plants and bugs have already gotten started before the bird gets here, it may not be at the peak and not be able to find as many bugs to feed those baby birds. So you've got the challenge of coordination there. Now some living things are adjusting. No surprise, they tend to be doing okay. Some aren't adjusting so well. No surprise, those are the ones showing declines. Here's an example of the general impacts of changing temperatures. This is a 1990 map showing different temperature zones for what types of plants you could reasonably grow in your yard. What's the temperature pattern? Say, okay, here we are, Boiling Springs. We're in the middle of this yellow zone. So zone 7, plants that do well in zone 7 are climates good for them according to the 1990 map. 2006, we're using the same zones, but they've moved. We're in Boiling Springs now, kind of right at the edge of zone 7, almost to 8. This is changing what types of plants would and would not do well in your yard or garden. And this is just over period of 16 years.